understand electricity and you know how easily a circuit can overheat, you wanna go ahead and leave the customer for the circuits. And everything is electric, everything is small connections, I'm gonna put the radio here, I'm gonna put this here, I'm gonna have the family over, so we wanna make sure that the customers have a good efficient circuit for their general receptacles. That's why when we install receptacles, we don't use 14, we only use 20, because that gives them at least an extra 5 amps of capacity for that circuit. We could save some money and the customer wouldn't even notice. I could put a 20 amp receptacle there, which we have found. We go ahead and we pull out a 20 amp receptacle, and it's not a code violation because the code tells us that if we have a 15 amp circuit, you can put a 20 amp receptacle. But why not put a 20 amp receptacle with a 20 amp circuit? It gives the customer, they think that they have 20 amps, so they'll go ahead and they'll plug in an 18 amp heater, right, for when they feel cold, and then that receptacle starts burning, the wiring starts burning because the receptacle doesn't have the capacity for that. So yeah, this is something that you guys are gonna understand. We're gonna talk about it. We're gonna go ahead and figure out how do we size our wires, and what is better for our installations, and what is the minimum standards in the code. So in order to be able to use our measuring tools, we have to understand Ohm's law. We have to understand what happens inside of our electrical circuits and how can we, in theory, right? I say in theory because all of the things, all of the mathematical operations that we do, we're just doing a mathematical calculation. But our multimeter is actually gonna show us if the circuit is working properly or not. So first we have to do a mathematical calculation in theory, and then we have to go and measure to see, okay, so this circuit is working properly because only 8 amps are supposed to be flowing through here, and I'm putting my measuring tool and 7.2 amps are flowing. So I'm close to that number. We can't be too far. We have a 10% plus or minus threshold for these kind of calculations. All right, so we have our measuring, what we say, this is the measuring values that we use to be able to calculate. So in our multimeters, these will have a symbol. So for example, alternating current in a multimeter will look like that. So alternating current and alternating voltage will have a V, and they will have a wiggly line on the top. Then our amperage will be also an A, a capital A, and it'll have either a straight line with 3 lines, which would be DC amps, or it'll be an A with a wiggly line on the top, and that will be alternating amps. Sometimes our multimeters will have both of them. They won't have them separate. They'll have them both in the same function, but that'll depend on what type of multimeter you buy. So you'll have alternating voltage and you'll have direct voltage. You'll have direct amps, or you'll have alternating amps. And then we have our resistance, which would be the omega, and then our watts, which will be the W. All right, so we talked about what type of current we have. We have DC current, we have alternating current, and we have 3 types of circuits. So we have our series, parallel, and we have a combination, right? And all of these will have rules that we have to follow to be able to solve them. So yesterday we said that the rules for series are that current has only one path to travel. Right? Our current in a series circuit will only have one path to travel through. It'll also, current is the same. So current is gonna be the same throughout the whole circuit. There will be no difference. So if we have the total current, we have the current that's flowing through any of the parts of that circuit. Then we have that, the total resistance of the circuit will be the sum of resistors. So you just take the resistance of 1, the resistance of 2, the resistance of 3, and you add it up. The total voltage will also be the sum of the voltage values in the circuit. So when we have the voltage of 1, the voltage of 2, the voltage of 3, the voltage of 4, you just need to add them up and you will have the total voltage of the circuit. The total power will be also the sum of power consumed by each resistor. So if resistor number 1 is using a certain wattage, 2 another wattage, 3 another wattage, 4 another wattage, you just need to add them all up and you have the total power of the circuit. So this type of circuit is very, very easy to solve because you just add up the values and the amperage is the same. So this is the easiest circuit to be able to solve. But I'm gonna tell you guys, if you don't focus on learning how to solve for series, like really focus on how to solve for series, remember what are the rules for series. When you get to parallel, it's gonna be confusing. Because when we get to combination, you have to use the rules for series and you have to use the rules for parallel. So getting down what are the rules for each one of them is gonna be very, very important so that you do well when you have to solve for your combination circuits, all right? All right, so let's go ahead and solve for a circuit. Now remember, do your chart on the bottom so that it's easier for you guys to go ahead and enter your value. So the first line is going to be our totals, our voltage total, our amps total, our resistance total, our power total. That is the first line. And all of the totals will be mixed up with each other. You can take the total voltage divided by the total resistance to get the total amp. You can take the total voltage divided by the total amperage to get the total resistance. You can take the total voltage, multiply it by the total amps to get the total power. Only totals with totals. Then we go with our other resistors. So we have resistor number 1, okay, so we have these charts are very helpful to keep all of your values organized. So for example, in this exercise, we have, we have 9 volts here, we have 6 volts here, and we have 15 watts. Alright, so how are we gonna solve this operation? These are all the values that we have. Had the voltage of resistor number 2. And because there's only 2 resistors, the logical thing to do is to take the total, subtract the voltage of 2, and that gives us 3 volts right here. So that gives us 3 volts right here. And then now having the voltage of 1 and the power of 1, I use this formula right here, which tells me that if I have the voltage and I have the power, right? I have voltage and I have power. At 1 amps, I take power and I divide it by the voltage, and that will give me amperage. So if I take 15 and I divide it by 3, that gives me 5 amps. So because I know that my rule tells me that current is the same throughout the whole circuit, I can take 5 amps and 5 amps here. And now I have 2 values here and 2 values here to be able to continue to solve for this circuit. So I want to go ahead and finish this one, so I'm going to take 3 volts divided by 5 amps, and that gives me 0.6 ohms. Are we following?
Mm-hmm.
Yeah?
Yeah.
All right. So we take 0.6 ohms right here because we took the voltage We divided it by our amps, and we got resistance. Now this one is done. I'm gonna go with the powers, so I'm gonna take 9 times 5, and that gives me
45.
45
watts.
yeah.
And I'm gonna take
Nine
9
right.
divided by 5, and that's gonna
Right.
give me?
1.8. Yeah. 1.8.
Now these two have to add up, so the number that I come up here has to give me
1.2.
1.8 total, right?
Yeah.
So 6 times 5 gives me
30.
30 plus 15.
Yeah.
Okay, so
45.
we're on track, right? These have to add up. If my numbers are not adding up here, then I'm not doing something right, or I'm not understanding what I'm supposed to do. If, for example, I have here 45 and 50, and my total is 45, then I did something wrong, right? It has to add up. The 30 plus the 15 has to add up here. So now I'm gonna take the 6 volts divided by 5, and that will give me 1.2 plus 0.6 gives me 1.8. So that means that my
1.8.
circuit is completely balanced. And this is what we have to do to be able to solve. We have to remember what formulas we have available, and we also have to remember what are the rules for a series circuit. Okay? Any questions? No?
No.
Like I said, these circuits are the easiest one to solve. When we get to parallel, now we have to think about other types of rules that have to apply for the circuit. Alright. Okay, let's add another resistor into the mix. I'm not gonna make up numbers, cause then my friends will go crazy. They'll be like, what is this? This doesn't make sense.
Makes sense.
Alright, so we're gonna have 3 resistors. For this circuit, we're going to have, let's see here, 5 ohms for number 1. I'm gonna have 3 ohms for number 2, 2 ohms for number 3, and we have 20 volts. Alright, so go ahead and solve for this circuit.
Oh.
Remember the rules and remember your formulas.
Yeah. Okay.
为什么不对呢？
对的。
我的天，这两个相乘的没打。
对啊，这样就40。哎呀，那个电流乘电压等于总功率。
我知道，